Welcome to this explainer. Today, we're diving straight into an incredibly practical implementation guide by Sana Hassan for monitoring and evaluating large language models. Look, if you're building AI applications right now, you already know that getting an LLM to just generate text, well, that's the easy part. The actual hard part is knowing exactly what it's doing, why it's doing it, and how you can systematically improve it. That is what true observability is all about. So today, we're going to build a comprehensive, bulletproof pipeline using Langfuse to achieve exactly that. Here's our roadmap for the explainer. We're going to cover setting up Langfuse, tracing the LLM pipeline, centralizing prompt management, scoring and evaluating outputs, datasets and experiments, and then bringing it all together. We are essentially building this glass box pipeline layer by layer, moving from that foundational setup all the way to advanced dataset experiments. Okay, so let's dive into the core issue here. How do we actually make LLMs predictable? Because honestly, it's arguably the single biggest challenge in AI engineering today. LLMs are notoriously unpredictable black boxes, right? You feed them a prompt, they give you a response. But that internal reasoning is often completely opaque to us. When things go sideways, like when a model hallucinates or spits out a problematic answer, you have to know exactly where that failure occurred. We literally need a reliable control center to trace and grade these outputs. So let's start with part one, setting up Langfuse, specifically connecting the client and choosing a backend. We start off by authenticating our Langfuse credentials inside the Collab environment and initializing the client. Now, what is really brilliant about this architectural choice is the setup itself. Normally, you'd hook up a real OpenAI API, which, as we know, requires an API key and eats up paid credits for every single generation. But here's the game changer. This pipeline lowers the barrier to entry by working entirely with a deterministic mock LLM if you want it to. That means you can learn observability, build out your tracing logic, and run really rigorous evaluations without spending a single cent on OpenAI credits. It is fully functional and completely free to test out. That brings us nicely to part two, tracing the LLM pipeline, where we'll be following the journey of a single question. Let's look at how the @observe decorator wraps our functions to capture their behavior. It's so simple. By just adding this decorator to our Python functions, Langfuse automatically creates a traceable generation observation. And this perfectly illustrates our manual RAG pipeline in action. In step one, we're retrieving context from an in-memory knowledge base, say pulling a fact like refunds take 5 to 7 days. Then in step two, we use this super powerful feature to propagate attributes, passing along critical metadata like a user ID, a session ID, and tags like support bot. And finally, step three, we pass that context straight to the LLM to generate the answer. The whole shebang is linked. So picture this. When a user inputs a query like, how long do refunds take, this entire multi-step process gets grouped together under one single umbrella. By tracing the specific refund query, we capture a unique trace ID. And why does this matter? Because frankly, that trace ID is your golden ticket. It's absolutely crucial. It allows us to securely attach subsequent evaluation scores, user feedback, and cost metrics to this exact interaction later on. It literally turns an isolated API call into a perfectly trackable, manageable event. Next up is part three, centralizing prompt management, or versioning your instructions. This is a massive shift. The system allows developers to pull hard-coded prompts entirely out of the codebase and into a managed hub. Just look at this system prompt template. You are a tone customer support agent for company. This is created and stored directly inside Langfuse. Then we dynamically compile it at runtime, injecting variables like friendly for the tone and Acme for the company. This separation of concerns, it's huge. It means your non-technical team members, like product managers, can jump into a sleek UI to tweak, version, and optimize prompts without ever having to touch the application's source code. Which brings us to part four, scoring and evaluating outputs. We are basically grading the RAG pipeline. The whole point of this is evaluating the quality of our traces using inline and retrospective grading. Sure, you have your trace, but was the model's answer actually any good? Well, we can seamlessly map different scores directly to that trace ID we generated earlier. First up, a numeric score for groundedness. This is a heuristic check to see if the model's answer actually mentioned that 5-day refund window we provided in the context. Next, we have a categorical score for user feedback, basically capturing if the user clicked helpful or unhelpful. And finally, a Boolean score, indicating the resolved state, just a simple 1 for yes or 0 for no. You can attach endless custom metrics here to figure out your model's real-world utility. Stepping back to look at the big picture, we hit part 5, datasets and experiments. It's time for running mass evaluations. So, moving beyond just single queries, we actually create a QA benchmark dataset natively in Langfuse to run bulk experiments. We populate our dataset with these rock-solid deterministic inputs and expected outputs. France mapping to Paris, Germany to Berlin, Japan to Tokyo, Italy to Rome. We do this for a very specific reason, to ensure that our experiment runs remain completely idempotent and repeatable. Think about it. When you update your system prompt, or maybe switch to a cheaper model, you absolutely have to run those changes against a fixed baseline. Otherwise, how do you know if your overall accuracy regressed or improved, right? Once that dataset is defined, Langfuse runs our specific task against it using item-level evaluators to grade the outputs. For example, it checks exact match accuracy, like did the model actually output the word Paris? And it evaluates conciseness by measuring the character length of the response, just to ensure the model isn't rambling on and being overly verbose. After scoring every single individual row, Langfuse runs an aggregate evaluator to calculate the overall mean accuracy of the entire dataset. This gives you a crystal clear, highly objective grade for your pipeline's current configuration. Finally, part 6, bringing it all together into the observability dashboard. We wrap the whole thing up by optionally tracing a LangChain execution if an OpenAI key was provided. But again, if not, that mock LLM works perfectly. Then we execute a command to flush all these buffered events straight to the cloud dashboard. And inside the Langfuse project interface, you get total visibility into your newly flushed data. In the Tracing tab, you got your detailed traces, complete with user tags. In the Prompts tab, you can manage your version support agent prompt. Head to the Scores tab, and you can visualize your groundedness, user feedback, and accuracy trends over time. And in the Datasets tab, you can easily review your Capitals baseline experiment runs. It gives you absolute, uncompromising visibility into exactly how your application behaved. So you now understand exactly how to build a production-ready observability pipeline. We took that notoriously unpredictable LLM black box, and we turned it into a fully monitored glass box. You have the exact blueprint to trace functions, manage prompts externally, attach really rigorous scoring metrics, and run bulk dataset experiments to absolutely guarantee quality. So now that you've got this kind of full visibility, what reliable AI application are you going to build next? Thanks so much for joining me on this explainer. Keep building, and I'll see you next time.